So this was all about of the dispersive IR. Now let's move toward the FT instrument or FTIR instrument, which is the Fourier transform instrument. The basic difference between the spectrophotometers, IR spectrophotometers, is that in case of dispersive IR there was monochromator, and here instead is Michelson interferometer. So this is the Michelson interferometer, which made this equipment, the FTIR equipment, very updated and very sophisticated. So the Michelson interferometer basically consists of two mirrors. One is stationary mirror and the other is a moving mirror and a beam splitter. When the radiations comes from the radiation source, these radiations that comes from the radiation source are in the IR range, and when these radiations strikes with the beam splitter, these radiations are divided into two beams. One radiation beam is moving towards the stationary mirror and the other is moving towards the moving mirror. So when the radiation reaches these mirrors, they are reflect back and recombines on the beam splitter. But in case of moving mirror, these radiations when reflects back, here constructive and destructive interference can occur. So based on the path length, change in path length, here constructive and destructive interference can do occur. But when these radiations reflects back from the moving mirror and from the stationary mirrors and recombine on the beam splitter, they are directed towards the sample. So these radiations are now diverse beam of radiations having diverse frequency and wavelengths. So these radiations are known as interferogram. So the interferogram is basically passed through the sample, and when these radiations are passed through the sample, some of the characteristic frequencies are absorbed by the sample, because the sample having certain molecules and those molecules are having certain functional groups that absorb certain frequencies. So when the interferogram passed to the sample, some of the characteristic frequencies has been absorbed. Now this interferogram is modulated interferogram, and this modulated interferogram are the beam of radiations in the time energy domain, which is not required for the construction of spectra. The system must convert this time energy domain into time frequency domain, as time frequency is required for the construction of spectra. So here is the complex mathematical calculation, which is the Fourier transformation. So when Fourier transformation occurs, or when the time energy domain is converted into frequency time domain, now these results will be required for the ultimate construction of spectra. When these radiations reaches the detector, it detects it, and the computer screen shows us the spectra in the form of results. Here you see a moving mirror which is directly connected to the computer. Here some of the radiations as a reference are moving from the moving mirror towards the computer, so as to compare these two radiations, that which of the radiations are absent in the modulated interferogram, so as to construct the spectra. So this is the working principle of the FTIR, where the spectra is constructed.